So I'm going to start out by saying I thought there was going to be like 20 people here. So thanks for making me nervous again. So I'm John from Canada. That's my whole bio. Actually, my whole bio normally is just famous ng-conf speaker. Now there's a bunch of us here, so I can't say that anymore. I'm a lead developer. Mostly I do front-end UI stuff and get tossed all the memory leak problems when they come up. You can go to this link if you want to look at the slides. There's a ton of notes that go into more detail. So just going to get right into it. So large-scale memory leaks. I don't know if anybody else here has ever had to deal with a gigantic memory leak, but I have, and people I worked alongside with had to also, and we spent multiple weeks trying to track down a memory leak, 6+ man weeks, and they're really tricky to solve when you're working in a giant application. And pretty much everybody in the project went from never having to think about a memory leak to being super well versed in hunting them down. And by the end of it, we were all super mentally drained and need to drain a drink about that big too. So hopefully, I hope some of the insights I give you in the walkthrough will let you hit the ground running and not need to drink margarita quite that size, because the aftermath wasn't super pretty. Okay, so my goal with this talk is mostly I'm going to run through memory, how it works in the browser. I'm going to give you a breakdown of all the tools that you're going to need to use. I'm going to let you understand how memory leaks happen despite the memory being managed for you, and why you need to care about memory leaks even if they're super tiny in your application. So there's really 3 types of memory issues, not just memory leaks. You have memory bloat, and that's going to be when your app uses way too much memory right off the bat. You have garbage collections. If they're happening way too often, you'll get jank in your app. It'll be choppy. Animations will they'll be visibly choppy. And then you have memory leaks, of course, which is going to be the core of this talk. Oh, wait, I had more slides, but I missed them. Okay, so frequent garbage collections, then memory leaks. So what is a memory leak? At a high level, it's pretty simple. Really all it is your applications are always going to be asking the OS for a certain amount of memory to store data in and execute tasks with. It uses that for a time, and when it's no longer needed, it should be released back to the OS. So the memory leak happens when that process where it should release it doesn't work properly. And that's when garbage collection fails you, and it's always your fault, or some other library that you're including. It's likely because there's still a reference to an object that you didn't know was there, right? So if there's multiple references to an object, say you reference in a component in somewhere else, so you have reference A, that's something you wrote, reference B, somewhere else in the application you're not even aware of it. You go, okay, I'm going to clean up reference A, say that's a component, you get rid of it, you expect the garbage collector to come through and clean up the memory for you, but it can't run until whatever that other object was gets unreferenced. Here's a simple example in Angular. It's pretty contrived, but you'd have a component and it's storing some part of that component, so in this case the element reference, in a service. So when that component's removed from the DOM, if you navigate away and it's deleted from your DOM and you no longer see it in your element list, you might think the memory should be freed, but because it's referenced in a service somewhere, it's going to stick around in memory. And in the tools you'll see that. You'll see DOM nodes still stick around even though it's not in your actual DOM tree anymore. So it doesn't matter if these leaks are really small or really big, if you're leaking next to no memory or a ton, because you have to imagine the user's use case versus what your development machine is. And when I'm working on projects, Webpack's running, a dev server, it's refreshing every, 30 seconds maybe even more. If there's a tiny memory leak, you're never going to notice it in that scenario. But your real users, they sit there with their machines running for a month straight. And the severity of the leak is going to matter, because if you think about the specs you have on your dev machine, you have 16, 32 gigs of RAM. Your real users might only have 2 gigs. So even really tiny memory leaks can, crash their browser, crash their computer, possibly. And then, like I said, the normal usage time of the app also comes into play. So if your app's only used for 5 minutes normally, maybe it doesn't matter if there's a super tiny memory leak, you should still probably try to fix it. But if your app's normal usage time is someone sitting there for 8-10 hours, maybe the normal usage is to leave it running for multiple days, then it can be a lot more important. And you always have your edge case users, your people that leave it on for 30 days straight, someone using IE10, IE9, anybody with a super low-end machine, maybe they only have 1 gig of RAM. And so why do you care? I mean, the gist of it is that all memory leaks, no matter the size, are going to cause performance issues for someone. And in the worst case, you crash the browser. And they're probably paying for your salary. Oh, wait, that's my note. That's not supposed to be in there. Okay, so yesterday in my talk I said there's 2 types of memory leaks, contrived examples and real ones. So this is contrived. It's not really that helpful, but we're going to do it anyways because you really can't show a real memory leak unless you have a massive application. It's pretty hard to do that for a talk like this. So we're going to run through some of the tools that you can use in Chrome. Try and give you a pretty quick rundown, but hopefully everything you need to know to target a memory leak. So the first thing, if you think you have a memory leak or you suspect it, I always will come in and use the timeline tool. So at the top, you have a few things in here. Is this big enough? You guys see it roughly? Okay. So you have a record button that will start a timeline. You have a few options up here so you can take screenshots. There's a memory option. You're of course going to want that on if you're looking for memory leaks. Then you have a few capture settings in here. And then you can throttle your computer, so you can pretend like you're a user on a slower computer, which can be pretty helpful, not specifically for memory leaks, also for other performance. So let's refresh this quickly. Okay, so you come in, I'll give it a second, and you want to run a timeline. How you should generally do it is you start recording a timeline, and then this garbage collection button here will run a major garbage collection, clean up anything that's not needed in the memory. So you run that at the start. Toggle whatever event you have in your app that you think might be causing the memory issue. So, I mean, there's one thing you can do in this app. I'd say that's a likely culprit. Run the major garbage collection again at the end, and then stop it. So there's a few things in here. At the top, it gives you a couple different timelines. So at the top you get animation performance, CPU usage, and then your memory. We're not going to be super concerned with those. What we're mainly going to be focused on is the memory here. So you get this graph of memory. And it shows you a few different things. So the blue line is showing you the JavaScript heap. The green line, which you can kind of see over here, is the DOM nodes. And then the orange line is the event listeners at the bottom. So this is exactly the graph you're not looking for. If you see it climbing up like that, sort of staircasing up, that likely means you have a memory leak or something is being added to your memory and not cleared up. I'll jump back to the slides quickly to show you what I mean. So the top is an example of a memory leak, and the bottom is the graph you're looking for. So if you look at the start and the end of both of these graphs, in general, you're going to want to see whatever level of memory you started at. That should be roughly where you end at the end of the graph. And this will be influenced by things outside of your app. If you're not running in incognito mode and you have plugins running in there, you might have extensions that are adding a little bit of memory to your page, like an ad blocker, or I don't know, if you have like an enhancement suite for a specific site or something like that. So it's a good idea to always do these tests in incognito, just to default disable your extensions. So I'm going to run through garbage collection at a fairly deep level, just so you know how it works in a browser. And really the point of this, I just want you to understand what garbage collection is and how it's working and why it exists. So there's a bunch of different types of memory management. At a super low level with assembly, you're managing the memory on the heap itself. And it gives you a ton of control, and as you go up, the control is kind of taken away from you, but it's simplified in how you use the memory. And JavaScript is a garbage collection, or garbage collected language. So everything you write in the browser is going to be garbage collected by default. So if you go through the different types, like manual memory management in languages like assembly, C, C++, you can control each bit of memory in your application. It's super powerful because you don't have to worry about the performance implications of a garbage collector, but it's also way easier to mess up. It's much easier for you to accidentally reuse memory that was still in use somewhere else, or forget to deallocate some memory, and you need to manually track each bit. You don't have something handling that for you. And then if you go one step up, you look at something like Objective-C that just keeps a reference count. So it keeps a reference to each resource in your application, and it's a counter that goes up and down, and when it hits 0, it just knows to collect itself. So you kind of get some of the power of a garbage collector managing the memory for you, but you don't have to worry about a performance implication because it just tosses it away. It doesn't have to run a cycle and decide, do I keep it or not? Then you have garbage collection. So that's it's tracking each resource, or each reference to a resource. And then it runs what's called a garbage collection. And in a minute, we'll go through kind of visualization of what that does and how it works in the browser. But it takes time to do that. And since a browser is only single-threaded, anything that's taking time away from your application is going to cause it to pause while it's running. So each browser has its own engine, and each engine implements everything a little bit differently. There's, specs now, and they try and adhere to them, but each of their garbage collectors are conceptually the same, but implemented differently. And what that's going to mean is you might run into an issue, a memory leak, with likely it'll affect all the browsers, but you might see it have a much worse effect in a certain browser. You might notice I'm using the Chrome DevTools because I like them the most, and I'm looking at the memory, and I'm not seeing much. Maybe I'm seeing a tiny memory leak, but not a ton. And I don't really test in the other browsers, but I'm getting reports from my users that something seems funky in IE, the app's slowing down after a bunch of time. So you open it up in IE with their tools, and you see the memory leak's actually huge over there. And that's likely going to be because the garbage collectors are implemented differently. Yeah, so if we visualize what garbage collection looks like, you have a user using your app, and in the garbage collector, there's basically two chunks of memory. You have a young generation or young space, and an old generation or old space where the memory is stored. And as they go through and use it, memory is allocated, so the dark green blocks are allocated and still reference memory. When they clear out, that's unreferenced. So they come through, and some memory is allocated, and then unreferenced. So that memory is no longer used in your application. That would be like a component got cleared up, and there was an array or something, and it's no longer used. But at this point in time, your app's still using that memory. It's not until a minor garbage collection comes and it runs what's called a mark and sweep algorithm that it clears out the unreferenced memory, and it will mark anything that needs to be retained. So that memory is still required by your app. That's some component or service that's still there being used. And the user continues to use the application. Some more memory is once again allocated, deallocated, and then a second minor garbage collection happens, and that memory is shifted over from the young generation to the old generation. So this is important because anything that sticks around in the minor generation, or the minor garbage collection cycle is very quick. If you're just sweeping memory out of there, it's going to take 1 millisecond. Worst case scenario, if it has to mark everything in there, it might take up to 25 milliseconds or so, which isn't a huge performance hit. But anything in the old generation, when a major garbage collection happens, that's like a minimum of 30 milliseconds and an unbounded upper limit on how long that garbage collection can take. So you have your minor garbage collections, and they're always dealing with a small amount of memory. 1 to 8 megabytes, this is memory that's frequently allocated and deallocated, not used for a long time. These are preferable. You'll see these happening in your application a lot more if you look at the tools and you look at what's going on with the garbage collector. There's tons and tons of minor garbage collections running anytime they need to. So the garbage collector is pretty smart, or it's been getting smart in the past few years. It schedules idle time, or tries to schedule itself in idle time, so it doesn't cause a performance issue. So if you can keep it to minor garbage collections and quick garbage collections, it'll try and fit itself into your program in really, precise tiny chunks so it doesn't cause an issue, so you hopefully don't see any performance impact. But with that said, major garbage collections are always going to take too long for that to really be feasible. So they can deal with the rest of your JavaScript heap. And if you look at an Angular app, even a very simple one, you're looking at probably 50 to 60 megabytes of memory. And they take way longer, right? So they are handling that mark and sweep on a larger chunk of memory. And they're also compressing any memory in there that has been retained for a while to stop fragmentation. So why is the memory leaking with garbage collection, right? The garbage collector is smart in when it's running, but it's kind of dumb in what it's doing. That's not to say it's bad, it can't know, it doesn't know your intention, right? So you're writing that code and you think there's no more references to an object, but the garbage collector is aware of everything, right? So it's aware that a reference still exists somewhere. And even if that reference is never used, it still exists and it can't clean that memory up for you. And the last thing I want to really drive home is, since it is single-threaded, the performance is super important. They're improving the garbage collector constantly, so the performance implications are less and less. But if you're at all concerned with smooth animations or smooth transitions between pages, watching what your memory is doing and how often the garbage collector is running is important to make sure those are as smooth as possible. So you get tickets from your users and they're never that clear. They don't really know what's going on. What types of things would they report to you that are going to make you think maybe I should look for a memory leak? The performance is degrading over time. That's the most likely sign there's a memory leak. If they start using it and your app's great, 4 hours down the line, people submit a ticket, that's likely the issue, a memory leak. If your app crashes after extended use, it could be a memory leak. It's not certainly that. There's other performance things that could be causing that, but it's a good reason to look. And if the performance is constantly slow, again, that's either memory leak or memory bloat. Either way, it's a memory problem. But with that said, the only real sign that you have a memory leak, the only real sign you have a memory leak is that the memory is going up, and you can look at the tools and see that, right? So those are things your users might report to you, and then you know to dive in the tools and at least check. Because even if your users are reporting that, and you know to look in the tools to see is the memory going up, that's the only sign, sometimes it's not that easy. If you can imagine you have a gigantic application and you have maybe a certain section of your app that is really tiny, doesn't do a lot, you know it works properly, so you're not going in there often, and users are reporting a memory leak, and you're going through your whole application trying to toggle all the events, seeing if anything is causing a memory leak in the tools. But you forgot to visit that one page because it's such a small unused portion of your app. That's where a tool like Redux can come into play and really help you. You can have a global state and a history of all their states. So you can replay exactly what your user was doing that led to the memory leak. Like you might be able to even send their entire history back to your server when they report a ticket. And that can just run you through and you'll know, oh, everybody that reports an observational sign of a memory leak is going to that exact page. So what's causing the leak in your app? I'm not blaming you for the memory leak. Well, okay, I am. It's almost certainly your fault, or someone else is on your team, so I just blame the new guy. That's what I always do, or the last person that quit. My point is just you won't have to dive into Angular itself or put the blame on the browser. It's almost certainly going to be something you did, and that's awesome. That means we can fix it, and it shouldn't be that hard, hopefully, but sometimes it is. So what are the most likely culprits of a memory leak? Detached DOM trees. This is what that first example was showing. But if you think about it, your entire DOM tree can be divided into subtrees. So if you imagine each of these different colors is a different component, then you have a root at the top. If you take away the reference to one of the components, you would think that clears itself up. But again, if you had a reference in the service like I showed in that example, it will actually retain the detached DOM tree. So when we were looking at the tools earlier, you could see the DOM nodes going up. And if you looked at the actual application, obviously nothing was being added to the DOM. And that's because the DOM tree every time was getting detached from the application. The second thing is long-lived observables. So some observables have a lifespan. Something like an HTTP request will always have a completed event, and it'll kill itself. It'll unsubscribe when that happens. But if you're constantly taking requests from a certain API, like say you're polling a stock market API and it sends something back to you every 5 seconds in a component, even if you remove that component, that observable still and subscription is still going to exist in memory and it will be retained. And that's why you always, just to be safe, always unsubscribe from observables. Even, might not be necessary, but it's a good safety procedure. And then there's the console API. You should have it turned off in production. There's really no reason to leave it on in your production app. But if you come in and you're in your development environment and you're trying to track down a memory leak, it's pretty easy to forget to turn off the console API or not even think about it and go through the tools and see the memories constantly going up as I navigate. Maybe you're logging events on navigation normally in development. And each of those objects that gets logged to your console stays around in memory until the console's cleared. And the console's not really cleared until you refresh the page by default, so it'll look exactly like a memory leak. And then you'll likely have components, if you haven't planned them out well, that are they'll behave like a leak. So any component that is just a list, for example, a list with no bounds. So maybe you're pulling some API and it adds something to a list every 5 seconds. If that list has no bounds and it can grow to an unbounded height, in the tools it'll look exactly like a memory leak. You'll see the memory constantly going up, never going down. You'll see the DOM nodes constantly going up as things are added to the list, if it displays in your DOM. It's not technically a memory leak, but you should treat it like one. You should fix it because it will behave like a memory leak. And then a lot of people's first idea to check the memory is to look at the task manager or the activity manager, and they might see the application's memory is just climbing like crazy. Is that actually a memory leak? Probably not. Your OSs are super smart at this point in time. They don't ask for that memory back until they need it. So if your application's idle and it did previously say need a gig of memory, and right now it only needs 100 megs, but your OS doesn't need the memory for anything else, it'll stay at a gig of memory until that memory is required elsewhere. Back to the dev tools. Okay, so we have a few more tools. The timeline is it's a really vague picture. It doesn't, maybe you can tell you have a memory leak. It's not guaranteed based on that graph. It's likely, but it doesn't tell you what's leaking. It doesn't tell you when that leak happened. So in the tools, if you go into profiles, it's pretty similar to the timeline. You have two different things you're going to want to look at. Heap snapshots will be a snapshot of all memory used by your application when you take the snapshot. And the allocation timeline is going to show you memory as it's being allocated and deallocated in your app. So if we refresh this quickly again. If we run an allocation timeline, you can see some memory, a really tiny amount, is constantly being allocated and deallocated. That's because of the counter counting up likely. But if I toggle it on and off a few times, you can see these blue bars stick around. So the blue is memory that is still retained. The gray is memory that's been cleared up. So I toggled the counter 3 times, and it looks like there was 3 memory leaks, really. So you can click on each one in the allocation timeline, and specifically see what memory is still retained at that point in time. And when you click on them, you get a few different columns here. So the constructors, each different type of object, I suppose, that still exists here. You have your shallow size, which is the amount of memory retained by that specific item, and then the retained size is the amount of memory it references. So if you look at these memory leaks, they're each around 600 kilobytes roughly, if we were going to guess. And if we look at the retained size of something like a counter component, it has a retained size of 640 kilobytes. You can come in, expand it, and it will give you some insights into what's happening in here. So this is where it gets really complicated when it's not a contrived example. Like for me, I can come in here and see there's a counter component, and there's not much else happening in the app, so it's really easy for me to see it. When you have a giant application with 300 screens and 100 different components and you're importing a bunch of different libraries, it's way more complex. The steps are still the same to try and figure out what is leaking, but there's just a ton more information you're going to have to look through. And it can take a very long time. So if we look through what exists in this list, we have the counter component itself is really small, but it retains 600 kilobytes. We have some objects, 10,000 of them, that themselves are 560 kilobytes, and then we have an array that's 80. So that's basically all the memory. And you can expand each of these things and click on the objects that exist in here, or hover over them even. And it'll tell you what is that object. So this is a native element, which will be an element reference for an app counter. Go over another random one in here. You'll see the same thing. Kind of looks like there's 10,000, maybe, of the same thing leaking. If you want more insights into what's happening here, you can also use the heap snapshots. So we kind of isolated with that the event causing it's toggling the counter. I mean, it's the only event, so it's pretty easy to isolate. So if we come in and we take a heap snapshot before, and then we toggle it one time and take another snapshot after, you can look at a few different things. So the snapshot by default is showing you all of the memory used in your application at that point in time. And you might need to look at this, but it's a lot to go through. Even in this tiny app, there's not much going on, and there's a ton of information in here for you to look through and trying to figure out what's sticking around. But a really nice thing you can do is you can have multiple snapshots, and you can compare between them. Compare between the snapshots, and that's just going to show you the new memory that was allocated after snapshot 1 was taken. And again, this is very similar to what we saw on the allocation timeline. And since the example is so easy, the allocation timeline was probably all you needed to solve this. But in more complex interactions in your app, heap snapshots can be very powerful. So we kind of got a few insights in here. The counter component's likely the culprit. There's a huge list of objects leaking. Let's see if we can solve what's going on. Is that big enough? So we've come into the counter component, and we look at what's happening. We're for some reason allocating an array of 10,000 items. That seems pretty contrived to me. I don't know why you'd do that. But I'm allocating it, and I'm not doing anything with this array again. What else is happening? I'm starting a subscription, and I'm not unsubscribing from it anywhere in here. But even with that said, why is this array leaking when it's not in the subscription, right? People always tell you any memory used in the subscription is going to leak outside. In the subscription, I just have this .count, and this .count is just a number. So your initial idea might just be that only that number should be leaking. But because of how the compiler works in TypeScript, when you reference this in here, it doesn't matter what comes after that. If this is referenced in your subscription, the entire class is going to leak into memory. So anything you did in there is going to leak. So if we were going to fix this, I guess we should store that subscription. And then on undestroy, we'll unsubscribe from it. And let's go back to the tools and see if that fixed our problem. I'll run a timeline because it's the easiest way to see if the leak's still happening. So I come in here, toggle it off, back on, off and back on, off and back on. Well, that solved the memory leak, and it wasn't supposed to. Interesting. Wait. No, I gotta restart Webpack. Give me 1 sec. This happened earlier. Well prepared. At least Webpack's getting quicker. All right, well, I'm just going to show you what you should have had to do because that shouldn't be fixing this. Okay, so if we come in the counter component, what else are we doing in here? The app service is initializing polling. So that counter counting up is an observable in this app service. So if we jump in there, we can look at the initialize polling function. Again, this is pretty contrived, but the first time you call it, it's starting an interval that's pulling out a number. So observable.interval just means every 500 milliseconds, it's going to increment a counter basically. And then it's sending that information out to my polling subject. So these subscriptions in here are being created and they're never being cleared. There's a bunch of different ways you could handle this, but like the other component, and I swear normally you do have to do this, so you'll have to store them and then unsubscribe. But services don't have an on-destroy event like components do. So you have to figure out, what time do you want these subscriptions to stop. So what we'll do is we'll just create another function that we call from the component when it gets destroyed that says stop polling. And all it's going to do is it's going to go through each subscription. And unsubscribe from them. And then, because of how polling works, we need to reset the initial subscription to true, so it does the right thing the first time through. And now the memory leak would actually be fixed once we call that in the component. So we come in, sorry, wrong file, into the counter component. We unsubscribe from the one subscription here. When we call app service.stop polling, we unsubscribe from the other two subscriptions or however many were created in the service, and the memory leak is actually solved now. So now I can go to the tools and show you guys it doesn't leak anymore because you haven't seen that yet. Well, I can show you I actually broke it. Oh. Need to initialize your arrays. It would have been really good if this had a memory leak now, though. I think that would have been funny. So, got a couple more slides. So, like I said, because of the different engines, you might have to use a different browser to try and figure out what the memory leak is. I personally like Chrome the most. I think it's the best tool. It has the allocation timeline. The other browsers don't have that, so it's a pretty big advantage. But with that said, there will be times you have to use the other browsers and the other tools, especially if a memory leak is only present in one browser. Yeah, so in conclusion, they're easy to spot, they're hard to fix. Sometimes they fix themselves and you're not sure why. It's not as easy as this made it look, and it was even easier than I expected, so that's really true now. It has a massive performance impact. It doesn't matter how small it is, someone out there is going to complain to you about a memory leak if you have one. All the browsers are different, so make sure you test in all of them. Make sure maybe you have your unit tests run in all of them, or at least you manually check each one. And the dev tools are awesome. They're super powerful. It's likely all you'll ever need to solve a memory leak. So yeah, there's the link again if you guys want to take a look, but thanks.